This is Physics 2212, Lab 2, which looks at distributed charge. This lab intends to determine the amount of charge on a piece of charged tape using a model of distributed charge, unlike the point charge that was used for the tape in the last lab. So the main Physics 2 principles, which will be elaborated on in a second, are electric force and distributed charge. And the primary result that was found was that a glow script model was able to visually and computationally represent the distributed charge across two pieces of tape, which causes one tape to float above the other through repulsive forces opposing gravity. So the Physics 2 principles are first electric force, which is the electric force of object 1 at the location of another object. And this is equal to the electric field of object 1 multiplied by the charge of the object that's acting on our object 2. So the charge itself can be shown as either a point charge, where all of the charge is assumed to be in one single point, or shown as distributed, where it's evenly distributed across the entire surface or mass of the object. So each total charge can be divided by the number of pieces to yield dq, or the change in charge per piece. And then the force on each piece can be determined and summed to find the total electric force on the object. So the experiment to get data for this lab is the exact same as lab 1. So two pieces of tape were given a negative charge through fast removal from another piece of tape. And then they were held very close together so that the repulsive forces between the two negatively charged tapes would oppose each other, pushing away from the gravitational force on the top piece and making it appear to float. The length of the top piece and the distance between the two tapes during the floating was then measured. Some assumptions that could also lead to possible error within the calculations were that the charge of each tape is equal and evenly distributed across each tape's entire area, and that air resistance on the top tape as it floats was negligible enough to not count towards any calculations. So to computationally look at this distributed charge, I first modeled each tape as a line of points, each with charge q over n, so q being the total charge of tape and n being the number of points per tape. And for q, I just used that initial charge number that was found within lab 1, and it can be edited later on to actually find the total charge. So then I computed the electric field from each lower point on each upper point. Then I was able to sum those electric fields at each point from each of the lower points, and then multiply it by the charge of that point to determine the net force. Then finally, once I got the net force at each of the top points, I was able to sum them all together to determine the net force on the total top tape. So the next step would be to compute the gravitational force on the upper tape, and as you see below, I just used mass times the gravitational constant 9.8, and then I altered the value of the tape's total charge, Q, that was shown in the last slide, until the computed electric force is equal to the gravitational force, because the charge that was found in the first lab might not be the actual charge that's on the top tape. So after a bit of trial and error, I was able to find that the charge on the tape based on the distributed model was negative 1.5759 times e to the negative 8 coulombs. Using the previous calculations from the computational model, I was also able to create a visual representation of what was happening with the two tapes. So as you see below, the white arrow shows the total electric force, which is pointing upward from the repulsion from the bottom tape. And then the green arrows show the electric field at the top tape from the bottom tape. And that electric field is pointing down, and then the negative charge of the top tape reverses the direction of that arrow, yielding the upward white arrow in total. Then the yellow arrow is just that gravitational force downward, and as you see, the white arrow and the yellow arrow appear to have relatively equal magnitudes. Finally, I was able to compare the net charge that I found within lab 1 and the net charge that I was able to find now using the distributed charge model. So these were different by about a factor of 10. So the first charge was 5.75 times e to the negative 9th, and that's using the central point charge model. And the net charge determined using the distributed model was 3.5 times e to the negative 8th coulombs. So the distributed model can be assumed to be more accurate. And that's because the whole tape was charged during its removal, not just one central point. The whole tape was in contact and the whole tape was ripped off. And that charge is going to cover the whole thing. It's not just going to go to one point. And so each part of that bottom tape has charge, and it's going to repel several parts of the top tape, not just one point vertically upwards. And so that's why the net charge is a little bit larger than it was found using the point charge model. Thank you.